Sorry, technical difficulties, didn't have the board unfrozen. So, here we go. Just a quick review. Now, when we say exact value, that means we want radicals, no decimals. Okay? So, if this is a 45 here, 45, 45, 90, that means these are the same. And we're going from here to here, we're going to divide by radical 2. But we cannot leave our answer like that with a radical on the bottom. So, 34 radical 2, over 2, 17 radical 2. Now, if we did not need an exact value, we could have done this and just divided and got a decimal. We could have also used trigonometry. And we could have found either one of the legs using the hypotenuse and either the opposite or adjacent side. Okay? But since it said exact value, this is a review of what we know. This is 30, 60, 90. This is the short leg. So this one's easy. Hypotenuse is just double that. And the long leg is 13 radical 3. Now here, decimals are okay. Since we don't have any angles, we are doing a squared plus b squared equals, is the most important, c squared. So 5 squared plus b squared equals 12 squared. So b squared is going to be equal to 12 squared minus 5 squared. We'll just type in our calculator, 144 minus 25, and we get b squared equals 119. And we take the square root of that, we get 10.9. That's our b. And again, we check and make sure, does our answer make sense? Yes, because it's less than 12. All right, here, the new stuff, there's our angle, big X. We have the adjacent side, and we don't have that. We have the hypotenuse. We do not have the opposite side. So A and H is cosine. So cosine of an unknown value is x equals adjacent over hypotenuse. And then we just take our calculator and we're going to do the inverse. So second cosine 15 divided by 17. About 28 degrees rounded. Okay, so let's get into the new stuff, which is just putting this in the real world. So, we have angles of elevation. So that's if we're looking upward at something. The angle is formed between the horizontal and the line of sight when looking upward. Horizontal usually being, where your eyesight is, okay? And then the line of sight. It's not usually always the ground because, if you're standing up in the air, your horizontal from your eyes is what we're talking about. And then the angle of depression is the angle formed between the horizontal and the line of sight when looking downward, okay? So if we look at this, notice how we have 47. Why is that? Because of alternate interior angles. Okay? So it says from the top of the lighthouse, a jet ski on the water, sighted on the water, at an angle of depression of 47 degrees. If the lighthouse is 42 meters high, how far is the jet ski from the base? Okay? So our angle is 47. And we can put it, even though we're looking at it downward, we can put this inside the triangle, which makes life easier because of alternate interior angles. We have opposite, and we're trying to find adjacent. So O and A is tangent. So tangent of 47 equals opposite over adjacent. And remember, X on the bottom, we just switch these. So we take our calculator, and we're going to do 42 divided by tangent of 47. Now remember, we don't know what the distance is yet, And so we don't have the hypotenuse, we don't have really to compare to, but about 39.17 feet. Okay? So even though the drawing makes it look like it should be longer, it's just a drawing. So don't worry about that. That is an appropriate answer. Okay? When a ladder is rested against a tree, so, you draw a tree. Great tree, isn't it? With a hole in the tree. Okay, so there's my tree. We can make apples if we want. Make it your own. Okay, so we got a ladder resting against a tree. The foot of the ladder is 1 meter from the base. So that's kind of a long line, but it could be a tall tree. So it's 1 meter from the base. And forms an angle of 64 degrees to the ground. How far of the tree does the ladder reach? So in other words, we're trying to find this measurement right here. So we're trying to find the opposite measurement. We have the adjacent measurement. Hey, look, the hole in the tree is an O. So that is OA, tangent, of 64 degrees equals our unknown over our adjacent. So times 1, that's not too tough. It's basically just tangent of 64 degrees. So about 2 meters. Once again, I did not draw the scale, I was just drawing it. The small ladder. Okay, comfortable stairs have a slope of 3/4. What angle do the stairs make with the horizontal? Okay, so in other words, this angle right here. So that is our opposite. This is our adjacent. So we're doing tangent again. Tangent of an unknown amount equals opposite over adjacent. So we're going to do the inverse. So we're trying to find the angle. So second tangent, 3 divided by 4. About 37 degrees, rounded. One of Canada's tallest trees is the Douglas fir on Vancouver Island. The angle of elevation measured by an observer who is 78 meters from the base. So here's our tree again. That doesn't look like a fir tree, but whatever. Or get lines on it. Whatever. Okay, there's our tree. The person is 78 meters from the tree. And this angle is 50 degrees. How tall is the tree? Well, I guess I should have drawn it up to the top of the tree, but good enough. So we're trying to find this measurement. So that's tangent again, because this is opposite and this is adjacent. Tangent of 50 degrees equals opposite over adjacent. So since x is on the top, we're going to multiply by 78. That looks like 28. 78. So we take our calculator and just do 78 times tangent of 50. About 93 meters tall. And that's it.